All right, so moving on here, we got the function f of x is equal to negative 7.5t plus 60. So represents the amount of water in gallons remaining in a tub after 2 minutes. So I don't see an inequality, so this tells me that this is an equation. So I want to be able to find some information, and if I notice, it is the same as being in y equals mx plus b format. So it's y equals negative 7.5x plus 60. And when it's in y equals mx plus b format, I already know some information. I know my slope. My slope is negative 7.5. And if I turn that into a fraction, it's going to tell me how it moves. So I'm going to do negative 7.5, math, frac, enter. And it's the same as negative 15 halves. Negative 15 halves, same thing. And I know where my y-intercept is. It's 60. So I'm starting off at 0, 60 on the y-axis. Okay. And then I need to figure out what my x-intercept is, but I'll figure that out in a second. So here's what we're going to do. We're going to go ahead and write the meaning of this. So this says that the tub starts with $60 what? Gallons, 60 gallons of water. The tub starts with 60 gallons of water. Okay, so what's happening to the water looking at my slope is, am I gaining or losing water? Looks like I'm losing water. I'm losing 15 gallons in how many minutes? 2 minutes. So every 2 minutes, and I'm going to abbreviate minutes, M-I-N-S, since we're running out of space. So every 2 minutes, the tub loses 15 gallons. And you could add of water if you wanted to. Okay, so I'm going to kind of cheat and use my calculator to help me graph this. I'm going to go to negative 7.5x plus 60. And I know I'm going to have to do a window adjustment because my y-axis only goes up to 10. So I'm going to take it up to 100, but I'm going to count by tens. So I'm going to graph this. And I don't need any negative x's because we're talking about minutes. So I'm going to go back to my window and I'm going to cut off some of those negative x's. But I'm going to leave it at positive 10 because I can now see my y-intercept. So what I'm going to do now is, because I have 10 marks going up here, I know I'm counting by tens. So I'm just going to do every other even. So I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Ooh, I accidentally wrote 80. We're going to pretend that's not there. All right, and I know I'm counting by ones on my x-axis. So again, I'm just going to only write the even. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I just don't want my y and x-axis to be crowded. So I'm going to go to my table and I'm going to get some good points. So I know 0, 60, 2, 45. So halfway would be 50. Halfway between 50 and 40 would be 45. At 4, I'm at 30. So it's halfway between 20 and 40. At 6, I'm at 15. So if this is 10 and that's 20, 15 is halfway in between. And then it looks like at 8 seconds, I have 0 gallons of water. So I'm there. And now I want to ask myself, I want to connect it. Well, is time something that we skip x values in? If we're measuring time, do we skip time values? And the answer is no. When we are measuring time, we are continuously measuring time. So we want to connect these. So my x-intercept is at the ordered pair 8, 0. And my 0 is x equals 8. Now, these are saying the same thing, so I'm going to combine them into one meaning. So I'm going to say it takes the tub 8 minutes to drain. And when it's drained, you know that there is 0 gallons of water. And I'm going to put 0 gallons. Okay? 0 gallons. It's emptied. That's what that x-intercept is telling me. It's telling me how long it takes me to drain the tub. All right, so let's look at a solution to an inequality. Remember, for an inequality to be a solution, it has to lie in the shaded region or on a solid line. you can plug in a test point, and if you get a true inequality, you know that it is also a solution. So there's two ways that you can check an ordered pair to be in that solution set. So we're going to check for 0 in the solution to the inequality. And we're going to use the inequality above. We're going to use 3x minus 2y is greater than 4. Okay, so I could plug in the ordered pair for that to see where it lies. Or what I'm going to do is I'm actually going to plug it into my inequality. If they give you the inequality, it's faster to just do the math because you can just check it in your calculator really, really quick. So again, I'm going to plug in my x value of 4 here and my y value of 0. And now I'm going to do the math. So I'm going to use my calculator and I'm going to say 3 parentheses 4 minus 2 parentheses 0. Is this answer greater than 4? So I'm going to ask, is 12 greater than 4? And the answer is no. So it is not a solution. Mark out yes. Okay? So this ordered pair would either be on the broken line, or somewhere where it is not shaded. All right, let's do 0, 0. So I'm going to do the same thing. I'm going to say 3 parentheses minus 2 parentheses greater than 4. And I'm going to plug in again for my x value. This time it's 0. And my y value is also 0. And now I'm going to do the math because I want to see what is 3 times 0 minus 2 times 0. 3 times 0 minus 2 times 0. And that answer is 0. Is 0 greater than 4? And it is. This answer is... It is not greater than 4. And I messed up on the first one. It actually is a solution. I'm not thinking today. 12 is greater than 4. I was thinking less than. All right. So, prove that it is not a solution. So if you want to prove algebraically, again, all you have to do is plug in. So we're going to plug in 3 parentheses minus 2 parentheses greater than 4, and I'm going to plug in my x and y values. Let's see if my math skills improve this time. So it's going to be 2, and the y value is 1, and so now we're going to do our math. So I'm going to do 3 times 2 minus 2 times 1, and I want to see what that answer is. 4. Is 4 greater than 4? If I have $4 and you have $4, who has the greater amount of money? Well, nobody, because we have the same amount of money, and your dollar amount is not bigger than my dollar amount, so this is false. So it is not a solution. False. Not solution. Okay? That's what false means.